Kyle. Okay, so we've got a couple in situ measurements we make of the soil. This is a redox potential. So this tells us, based on the measurement we get, what types of reduction reactions are occurring in the soil. And we'll get a measurement in millivolts. And there's a particular range associated with iron, nitrates, that kind of thing. And so we can go back into the lab and determine what types of reduction reactions are going on. This is a multimeter. It's a little bit rough. It measures both pH and soil saturation, which is not the same as soil moisture. Soil saturation is the percent of pore space that is filled with moisture or water. And so this measures it through conducting electricity across these plates. So next we're at our T1 number 3 sample, which seems to be our favorite today. So Stephanie will demonstrate how to use each of these meters.
Okay, so for these two things, usually you're supposed to let the soil that you make a slurry out of to test the redox or the pH if we had a similar pH meter. Usually you want to let that equilibrate a little, so I'm actually going to collect the soil for that first. And then we can make the slurry, and then we'll do the saturation. So we're going to take a core the same way that we did previously. And place it into our bag. So remove a little bit, and it's good to take note of the depth of soil that you collected. Usually you have if you're collecting topsoil, you might want to do 10 centimeters, 30 centimeters, but it's something that you should take note of. So once we have the soil in the bag, we're going to add water until we get about a 1-to-1 ratio. And it's always good to at least start out with enough that you can kind of massage it and get it mixed up. The goal is to not really have any lumps in it. So depending on how dry the soil is initially and what the texture of the soil is, this can take a long time just because you really want to make it a slurry rather than having pieces of soil still in there.
Well, it looks good enough.
Okay.
You're such a perfectionist.
But there's potentially going to be small rocks that if you feel them, they're not going to mix up. So, okay, so you can see this is a slurry now. This is perfect for our redox reading that we'll do in a few minutes. I'm just going to let it sit for a bit because you want it to equilibrate. So we can do the saturation now. All you got to do with this, we don't have to make a slurry or anything, we just stick it straight into the soil.
You do need for this one, you do need some moisture in the soil. So if you were in a really dry plot, you couldn't really use this meter.
Okay.
And it can't be, it's sort of a fine range on this meter, so if you have standing water, you also can't use it.
Oh, okay. So it has to be that nice, kind of moist, but not inundated completely. Alright, so we stick it in. And you can see that the gauge is changing as it's figuring out what that percent saturation is. Do you want me to see if I can?
Yeah.
because it's kind of reflect the glare. Okay, so the bottom reading here is the percent saturation of the soil. So if you look at the bottom, you can see it goes from on the right 0 to on the left 100. So we're at about 25%. Okay, so this is the pH. Yes. Okay. All right. So when you stick the probe, or when you stick this in the soil, you might not know at first which setting it's on, but based on the pH here, wetland soil is usually going to be a little acidic. And this soil is pretty wet, so we're going to guess that the percent saturation is greater than where that line is right now on the gauge, around 25 or 30 or 40. So this looks like it's saying the pH is 6, so that's the top part. Then once we press this button on this meter, you can see that it's changing location on the gauge. So we switched from reading pH to now reading percent saturation. And that's the bottom black text, and it looks like it's right around 60%. So that would be what we record as the percent saturation. All right, so we have our redox meter. You can see it's not really in anything yet, but that measurement is coming from the bottom here, and we're gonna put this in our slurry, and you don't want it touching the sides of the plastic bag if you can help it. All right, so we put it in so that it's fully immersed in the slurry, but it's not touching the bottom of the bag. And then you can, it's probably hard to see, but
140.
the screen is reading 140, and if we wanted to wait a bit, we could see the range that it goes through, but it looks pretty stable right around 140. 135, yeah, 140. So
Yeah.
that,
Usually give it a few seconds to stabilize.
sorry. So now it's saying 145.
Yeah, that sounds, I think we're good.
Okay.
It's going up a little. Okay, so 145, I can't remember the range, but I think we're maybe down in the iron range for reduction there. So excellent reading, and what we would expect in soil like this that's been saturated for a long period of time.